Stop staring at dry textbooks and trying to memorize code. Programming isn't just a math test. It's a set of 7 secret superpowers you already use every single day. Your brain is already an elite programmer, you just haven't learned the vocabulary. Let's unlock it. Welcome to Think Like a Programmer. Forget about syntax errors and confusing symbols for a second. We are here to bridge the gap between human intuition and computer science, showing you exactly how your daily habits mirror the world's most powerful code. Let's first understand why algorithm order matters. Think about making a simple cup of tea. You boil water, add tea powder, sugar, milk, filter it, and serve for a perfect cup, is it not? But what happens if you change the order and try to filter the dry powder before adding water? You get a burnt, blocked, chaotic mess. This precise step by step sequence is exactly what an algorithm is. Because in programming, just like in kitchen, the order of your logic is the difference between a perfect result and a complete failure. So remember, algorithms require precise sequence. If order is changed, results could be chaotic. And likewise, every algorithm has its own purpose. Imagine you own a bicycle, a car, a boat, and an airplane. You wouldn't fly a jet to your neighbor's house, and you definitely wouldn't ride a bicycle across the ocean. Every vehicle is built for a specific terrain. Likewise, algorithms work the same way. As you can see on the screen, we map sorting algorithms for organizing data, search algorithms for efficient data retrieval, graph search for maps and routing pathfinding, and recursion for divide and conquering complex problems. Don't fly an aeroplane to your neighbor's house. Use the right tool for the right task. Next comes the first important brute force approach. We have all been there. You forget your 4-digit ATM pin, and all you know is that it's 4-digit long. So you start an exhaustive trial and error loop like 0000, 0001, 0002, and all the way to 9999 until it finally clicks. That's brute force approach, and it's beautifully simple and it's guaranteed to work eventually. But trying all 10,000 possibilities is incredibly slow and highly unreliable because the machine might lock you out, leaving us with one massive question: how can I become smarter? This leads to what is called as greedy thinking. To become smarter, we try greedy thinking, always making the absolute best, most immediate choice right now. Imagine you have 100 rupees and you want to maximize buying your chocolates. Your instinct is to greedily grab the cheapest one. So the price list is 10, 20, 30, and 50 rupees. The cheapest one is 10 rupees. Fine. So you try, resulting in a successful maximum of buying 10 chocolates for each 10 rupees. But greed has a strict limitation. Look at the second picture, test 2. If you need to make exactly rupee 6 change using rupee 1, rupee 3 and rupee 4 coins, a greedy path forces you to pick the largest rupee 4 coin first, leaving you with a suboptimal 3 coins total. Meanwhile, smarter choice selects two 3 rupee coins for an optimal 2 coin success, proving that best immediate choice can sometimes make the overall solution worst. That's greedy limitation. This leads to one other interesting solution called the dynamic programming, the DP approach. When problem gets repetitive, we use dynamic programming. Imagine a rabbit hopping up 10 stairs, taking either one or two steps at a time. If you map out every single path using a naive recursion tree, you will notice you are calculating the exact same step combinations like function 7 over and over again. wasting massive amount of time and creating slow repetitive work. Dynamic programming fixes this with a simple rule. The rule is this: remember plus reuse. By calculating a step once and storing it in a fast memorized DP table, the rabbit speeds right to the top without ever wasting energy solving the same riddle twice. Next comes a very interesting solution called backtracking. When simple choices fail, we need backtracking, the ultimate algorithm of exploration. Look at problem number 1. If you are guessing a 4-digit PIN, you don't just blindly reset. You type a sequence, hit a wrong digit, delete it, go back one step, and try the next number in an exhaustive trial error loop. But it gets even more powerful in problem 2. Look, with a 9 cross 9 Sudoku grid, instead of random guessing, the algorithm places a number, checks for a strict constraint satisfaction, and the moment it hits a failure, it immediately backtracks to try another path. This smart search cuts out impossible paths early, making it very essential for highly constrained problems like n-queens, knapsack, or solving a Sudoku puzzle. Next comes the divide and conquer approach. Fine. You already use divide and conquer approach naturally every time you look up a word like banana in a dictionary. You don't just start flipping from page 1. You open right to the middle, realize B comes before the middle page, and instantly make half the book disappear from your search range. By repeatedly cutting the remaining search space exactly in half, a massive task that should have thousands of steps is conquered in just few quick moves, right? Showing that humans already use this exact logic to locate items quickly. Finally, there is graph thinking, which powers the magic behind Google Maps. Forget the heavy mathematical formulas, just look at it intuitively. Every city is a node, every road connecting them is an edge, and your only goal is to find the path with the shortest travel time or the shortest wait. By visualizing the world as an intuitive network of connected dots, your brain instantly skips the longer 25-minute path to find the perfect 15-minute route, proving that the highest level of computer science is just structured human intuition. Fine. So computers are incredibly fast, but they are completely blank states. They don't run intuition, but you do. The best code doesn't come from memorizing a language. It comes from taking the natural, brilliant logic your brain already uses to solve real world chaotic and translating it to a machine language. Tap into your intuition, change the way you look at problems, and you don't just learn to code, you will start thinking like a true programmer.